Recording now, right?
Yay.
So with an ellipse, an ellipse is generated by having 2 points called the foci, and finding all the points that are whose when I add up the sum of the distance from one of those points from here to here and here to here, that number is, if I add this piece plus this piece together, if that number is always the same, meaning it's a constant, then I get an ellipse. So if I were to take like 2 pins, this is kind of the way they demonstrate this, and a piece of string or something, right? Like that's on, and I were to spin this piece of string around, what I do is I end up generating an ellipse. So this plus this and this plus this would be the same length. And if I take this plus this and this plus this, I would generate this ellipse. Okay? And you see ellipses a lot in real life. Anyone know where you find those things in real life? Car headlights. Yes? How about in orbits of satellites and planets and stuff like that? Because these might represent, like in astrophysics and stuff, might represent gravitational pulls of different objects, like maybe of planets or something like that. So if a satellite or something is traveling towards this place, it's pulling harder over here, then it kind of lets go. But these 2 forces added together.
I thought car headlights were parabolas.
I think some of them are parabolas and some of them are rotations of ellipses.
I don't know. I guess
Like
you'd
the
have to
orbit
go
of the
to
Earth around the sun.
orbit of the Earth around the sun.
Because when you're closer to the sun, you move faster.
Good point. Yeah. So there you go.
Said
We did
orbits
this.
of planets.
Yeah, if it was a parabola, we just keep going forever and ever, right?
Yeah.
Into outer space. So,
We
no.
would have to
So in any case, going back. All right, class. Let's go back. And standard form of an ellipse is x minus h plus y minus k over a squared plus b squared, where h, k are the center of the ellipse. Okay, and a and b are called the 2a and 2b are the major axis and the minor axis of those of that ellipse. So the major axis is always the one that has the focus on it. Okay, with an ellipse, which is not the case with the hyperbola, which I'll talk about tomorrow, but with an ellipse, a is always bigger than b. Okay, so whichever number is bigger, that's which thing comes, that determines which way it goes. So if a is bigger, then it looks like this. If a is bigger, and it goes under the x like this, then it looks like this. If the a, which is the bigger number, is underneath the y, then it looks like this, and the foci are along the y-axis. Okay? Okay, so this is the equation of an ellipse going this way. This is the equation of an ellipse going this way. And A, B, and C, A is the distance from the center to the vertex, not to the focus. B is the distance from the center to this point up here, which is a point on the minor axis. In this case, this point is B. Okay? And the focus is the distance from the C is the distance from the center to the focus. Okay? And they're related by this equation: c squared equals a squared minus b squared. Center at hk. And again, with all these, I don't like to have a whole bunch of equations or more things that I have to memorize. And my pen just froze. So I don't know what I'm going to do. I'm going to stop.